lesson 6.7 is on the multiplication principle. We're going to talk about tree diagrams, and we're going to show how we can use the multiplication principle to find the number of ways something might occur. Well, let's start off with a very simple example. The breakfast special at Mel's Diner offers eggs, served either scrambled, over easy, or poached, and bacon or sausage. How many different breakfast specials can be ordered? So we're going to use what I call a tree diagram, and it's called a tree diagram because of the way it branches out. And I'm going to start out with one spot right here. My first choice would be eggs. And so what I'm going to do is I'm going to write this out and branch it into three possibilities. Because there are three possibilities for the eggs. They can be scrambled, they can be over easy, or they can be poached. Now, after you choose what type of style that you want your eggs cooked, then you have a decision to make whether you want bacon or sausage. So let's say we decide on scrambled. Well, if we decide on scrambled, we still have to decide, do we want bacon or do we want sausage? If we had decided on over easy, we still have to decide on whether we want bacon or whether we want sausage. If we decided on poached, we have to decide between bacon or sausage. And you can see why they call this a tree diagram because of the way it branches out. If I look at from here to here, it goes scrambled, then goes to bacon. This would be scrambled and bacon. From here to here, this would be scrambled, if I can spell it, and sausage. Oops. Similarly, if I go to the middle and I have over easy, I can have over easy bacon, over easy eggs and bacon, or I can have over easy and then the sausage. Okay, if I pick poached, I can have that with bacon, or I can have poached with sausage. Now, I took all this time and wrote all this out, not to waste your time, but to show you the 6 possible breakfast specials that can be ordered at Mel's Diner. Now, I knew there were going to be 6 even before I started writing all this stuff out because I had 6 final branches. 1, 2, 3, 4, 5, 6. That told me how many different breakfast specials there were going to be. I didn't have to necessarily write them all out because that's not what it asked for. It just says how many different ones are there. And my answer is 6. Okay? Because of the 6 that I have written down. I went ahead and wrote them out so you can see that just a little bit more clearly. Here's another example. A sandwich shop makes egg salad, tuna salad, or ham salad sandwiches using either white or rye bread. Make a tree diagram to count the number of possible sandwich choices. So here we go again. We start with the dot here. I guess that's us. And we can have egg salad, tuna salad, or ham salad. So we can have egg. I'm just going to put an E here for egg. We can have tuna. I'm going to put a T here for tuna. And then I'm going to also have ham. So I'm going to put an H here for ham. Then, if I choose egg salad, I can have it on white or rye. So from here, I can have it on white or rye. For tuna, the same thing. I can have it on white or rye. And for ham, I can have it on white or rye. And you can see that I have, just like the last example, they're not always exactly the same. It's just a coincidence here. I have 6 possible sandwich choices. I can have egg salad on white, egg salad on rye, tuna on white, tuna on rye, ham salad on white, ham salad on rye. There are 6 possible choices. Now, it seems to be kind of a hassle, if you want it, for having to draw one of these out to be able to figure out how many choices there are. It's nice because you get a picture of what's going on and you can write out all the choices like I did primarily with the earlier example, but there is an easier way to count the number of possible outcomes when you have these different events occurring. And it's called the multiplication principle. Sometimes it's called the multiplication principle of counting. And it says if one event can occur in m ways, and for each of these ways, a second event can occur in n ways, m ways, n ways, different there, then the number of ways that the two events can occur together is m times n. Multiply here. That's why it's called the multiplication principle. You're going to multiply the number of ways the first one can be done times the number of ways the second one can be done. So if I go back to my sandwich shop problem here, right, I have 3 choices for the different types of salads salad sandwiches, and I have 2 choices of bread. And if we multiply these together, we get the same answer as we had before. Now I'm going to use that on a variety of problems. I'm going to start off here with one that involves flipping a coin and rolling a die. It says how many different outcomes are possible when you flip a coin, we'll assume a fair coin, and roll a number cubed or a die. Well, there are 2 possible outcomes when you flip the coin, heads or tails, and there are 6 possible outcomes when you roll the numbered cube or the die. And that would give me 12 possible outcomes. I could have, for example, heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, tails and 1, tails and 2, and so on. There would be 12 different outcomes that could be possible. A yogurt shop offers 18 flavors of frozen yogurt as well as 3 types of cones and 12 different toppings. Assuming that a frozen yogurt consists of 1 cone, 1 yogurt flavor, and 1 topping, how many choices are possible? Well, we definitely would not want to use a tree diagram. It would take way too long. Instead, we're going to use the multiplication principle of counting here. So we have first a cone, right? There are 3 different kinds of cones. Then yogurt flavor. There are 18 flavors of yogurt. And then toppings. There are 12 types of toppings. We're going to multiply these 3 numbers together. The number of choices of cones times the number of choices of flavors of the yogurt times the number of choices of the toppings. And we get, if I'm not mistaken, 648 different possible frozen yogurt orders. So you can see why you wouldn't want to use a tree diagram there. All right, now we're going to use the principle of counting to help us with a couple of probability questions. First one, you flip a coin, a fair coin, 4 times. How many possible outcomes are there? And then what is the probability that the coin shows heads each time? So let's answer the first question. How many possible outcomes are there? Well, the first time you flip the coin, there are 2 possible outcomes. It's heads or tails. The second time, the third time, and the fourth time. And again, because of the principle of counting, we are going to multiply the number of ways the first thing can happen times the number of ways the second, times the number of ways of the third, times the number of ways of the fourth, and that gets me 16. So there are 16 possible outcomes when you flip a coin 4 times, right? It could be tails, 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 or it could be tails, heads, heads, tails. There are lots of different ones to list out, but we want to know now, in the second question, what's the probability that the coin shows heads each time? Well, the probability that there are 4 heads, there's only one possible way, a favorable outcome of getting 4 heads, so that would be 1 out of 16. Now the second question, I've drawn a spinner. Each of those sectors are supposed to be the same size, and the spinner is equally likely to land on any one of those 4 spots there. It says you spin the spinner twice. What is the probability that the spinner lands on a 1 and then it lands on a 2? Well, the first time you spin the spinner, there are 4 ways that can occur. You can get a 1, a 2, or 3, or 4. The second time you spin the spinner, there are 4 possible outcomes. So that means if you spin it twice, there are 16 possible outcomes. You could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, and so on down the line. All right, now what we want is the probability that it lands on a 1 and then it lands on a 2. 1 the first time, a 2 the second time. Well, that's one way that it can occur. I can get a 1 and then I can get a 2. In that order, only one possible way. So the probability of getting a 1 and then a 2 would be 1 out of 16. Same answer as the last one, but certainly a different problem. All right, make sure that you look this over and don't forget to practice, practice, practice.